So here is our CGI problem for the day. It says, Cameron loves to build with Legos.
I do.
He wants to build an entire city and will need packs of Legos. Each pack costs some amount of money. He goes to the store some amount of time. How much did he spend? Solve with at least 2 methods. What is the extra information? Why is it extra? So let's think about this. Which number set are we going to choose? Okay, so we're going to choose this one. Okay, so let's unpack this problem. Let's take it apart. So Cameron loves to build Legos. He wants to build an entire city and will need 59 packs. So I'm going to write that down. Needs 59 packs because I see that as information in there. Okay? Each pack cost so many dollars. So each pack
Costs $28.
and we chose $28. Okay? He goes to the store blank times. Goes to store 150 times. How much did he spend? Okay, so what is it asking me to solve? It's asking me to solve how much he had to spend. So what information, I wrote down all the information. What information do I need to figure out how much he solved?
I know one way.
So if I'm trying to figure out how much money he spends, I'm thinking that that I need to know. So $28, I'm going to keep that piece of information because that's going to be important for me. Okay? Now, one of these pieces of information, the 59 or the 150, I don't need to solve this problem. Which one do I not need to solve the problem? If I need to know how much he's spending, what's he buying? He's buying packs of Legos. So do I need to know how many packs he buys?
Yes.
To know how much he spent? Yeah, that makes sense. Okay. Do I need to know how many times he goes to the store?
Yeah. Oh, no.
No, why not?
Because.
Does that tell me about what he's buying? No. So I don't need this. This is extra information. Okay. Why is it extra?
Because.
So it doesn't really tell us about what he's information that we need to solve the question, how much did he spend? It doesn't tell us that information, right? So we don't need it. So now that we have the pieces of information that we need to solve this. So how are we going to solve this problem? What are we going to do with 59 and 28? So we're going to multiply. So let's do 59 times 28. What's one method that we could use to do this? Oh, I like how Cameron is looking back in his notes so that he could look at a way that he could solve this problem. So there's algebraic notation, there's expanded notation.
Maybe we can use.
The quick method. Okay, so I heard Seth say area model, and then are you talking about the quick method, Drake? Okay, so let's do both of those. So we're doing 59 times 28. So I'm going to do 59 times 28. So let's draw the area model. So I have my rectangle. And over here, I'm going to have 50, and what else?
59.
I'm 9, and then what are we going to have along the top?
20 and 8.
20 and 8. Okay? So, let's do this part first. What's this going to be?
50 times 20.
50 times 20. Okay? So we're going to do 5 times 2. What's 5 times 2?
10.
10. And we can't forget about this 0 and this 0. So how many zeros are we going to add to that?
Just 2.
2.
So 10,000.
Okay,
Well,
1,000. And I'll put that over here. Okay. Now let's look at this one. How are we going to solve this one?
50 times 8.
50 times 8. So what is that really? We're going to do 5 times 8, 40.
So 400.
But then we need to add that other 0, so it's 400. So I'm going to put 400 over here.
9 times 2. Oh.
Okay. And then Seth, for right here, you said 9 times 2 is 18. And then what do we do with that extra 0?
We put it down.
Put it down at the end. So 180. How about right here?
9 times 72. 8.
9 times 8, 72. What do we do with all of those numbers?
We add them.
We're going to add them. So 2 plus 0 is 2.
There, we got the answer.
15, 6. $1,652 is how much he spent on Legos. Jeez, Cameron. Okay, now let's try the quick method that Drake was talking about. So we're still going to do 59 times 28. So I'm going to get it. 59 times 28. And we're going to do it vertically. So I'm going to go 59 times 28. Okay, so first I'm going to look in the ones. And I'm going to do 8 times 9. What's 8 times 9?
8 times 9 is 72.
72. Now, how am I going to write that 72, Drake?
You put
I'm going to put,
7 on the 5.
so we're going to carry the 7 up here and put the 2. So we're putting the 7 up here in the tens place and the 2 down here in the ones place, okay? Now, we're going to do 8 times 5. What's 8 times 5?
40.
40. And then we're going to add that extra 7. So 47. Right? Okay, now we're moving over to the 2. But this is not really 2, right? It's actually 20 because it's in the 10 spot. So since it's in the 10 spot, I'm going to add my 0.
Imaginary 0.
Right? Because that's from the 20 because it's not just a 2. Then I'm going to do 2 times 9. What's 2 times 9? 18. So I put my 8 and carry my 1. I don't need that 7 anymore. Now what am I going to do? 2 times what?
9.
We just did the 2 times 9, so now we're going to do 2 times 5. 2 times 5 is 10, plus that extra 1 is 11. Let's add that and see if we get the same answer. $1,652. Is that the same answer that we got before?
Yes.
Yes. That was the quick method, so that would be the same as if we did 8 times 9 is 72. 8 times 5, but that's really 50, would be 400. Then 20 times 9 is 180. And 20 times 50 is 1,000. It's the same answer. So this week you're going to make a video about which method you like the best. Okay? You could do the shortcut method, you could do area model, you could do expanded notation, whichever model works for you. Okay?